Okay, folks, we are starting chapter 3, and it's going to be a quick one. What with already taking 3 days of class, I think, for now. Yeah, we're going to be rolling through it. Okay. Sorry, of course, the sneeze comes on. Excuse me, sorry about that. Okay, this is all about functions, and this is we do this after linear functions or linear equations because you can kind of form a linear function, so it's very related like that. And this first question is kind of determines the difference or determines the difference, shows the difference between linear and nonlinear functions. Okay. Um, and the difference between a relation and function. Okay, so 10 members of the photography club want to raise $500. So they will hold a raffle with donated prizes. And like the prices for raffle tickets are here, right? So there's two people that are like kind of like leading this, I guess, right? Jesse proposes that to reach their goal, each member should sell 50 raffle tickets. Cool. And Alexis proposes that each member should raise $50. So kind of if you don't really think about it, and you don't really pay attention to the prices, you could be like, oh well, those plans are exactly the same, right? Because if 10 members each sells 50 raffle tickets at $1, right, that's $50 each times 10 is 500. And then Alexis is like, well, each member raises $50 times 10 is 500. So it's kind of the same either way. But then you notice that there's actually a discounted rate as it goes up. Okay. So if you buy a single ticket, it's $1. But if you buy six tickets, it's $5. And if you buy 25 tickets, it's $20. Um, so um, what's going to happen is if people take Jesse's plan and they just are focused on selling 50 raffle tickets, if somebody wants to buy, uh, let's say you just sell them all to two people, right? And you sell 25 tickets to one person and 25 tickets to the other person. Well, that's $40 instead of $50, right? So you sold your 50 tickets, but you only made $40. So um, just kind of logically, right there, we should assume that Alexis is correct, right? So we would say Alexis's plan is better um, because you don't have to worry about the discounted tickets. Worry about the discounted tickets. And in class, I'll just kind of let people figure that out on their own. I'll give them like 5 minutes to talk about it, and they'll do that on their own. But the video is different. Okay, so this is the idea here, right? We want to determine if something is a relation or a function. Um, and and how to distinguish between those two things, right? So we can represent this a couple different ways. We can have tables, we can have mapping diagrams or arrow diagrams. I call them mapping diagrams, but I think the book refers to them as arrow diagrams. You can also have them as equations and as graphs. Um, and so the idea here is that each input corresponds to exactly one output, right? It's pretty easy to see on a mapping diagram because you can see your inputs here on the left, your outputs here on the right. Okay. Um, each input has one arrow going to it, right? Okay. If, for instance, the one had an arrow going to another number, then it would not be a function because you would not have each input corresponding to exactly one output. That one input would actually go into two different outputs, which is not what you want. Okay. So you can see it here, right? We have two inputs that are the same that are going to different outputs, right? So that would represent this on that two, right? It would be going to 4 and to 6 on the mapping diagram. So that's kind of the whole idea about today, right? Is figuring out what's a function and what's just a relation, because relation is the big category, function is the smaller category. Okay, so identify functions with mapping diagrams. Again, the book calls these arrow diagrams, but mapping diagrams because that's kind of what I've been using for the last 8 years. So Jonah's shipping 5 boxes for his uncle. Each box is the same size but a different weight. The cost to ship each is shown. So we have all these different weights of boxes and then different prices right here. So we have your input as the weight and the output as the price. And that's the idea. You can also think of those as your X and your Y. Okay. Um, so what we're going to do is we're going to put all these together in I'm just going to put them together in a mapping diagram. The book wants you to do like, put them together as ordered pairs and stuff. Well, actually, that is useful because it does, kind of like bring the relationship between the X and Y. Okay, let's do that. So we have 9 pounds here at 872, and then we have 8 pounds at 856 here, and then we have, let's see, 10 pounds at 901, 12 pounds at 955. And also, I guess this helps us put them in the correct order as well, and 14 pounds at 1003. So you can see here that each of our inputs are X values, right? Because there are, right? It's an ordered pair, right? So ordered pair always has an X and a Y, right? All of your X values are your inputs. And actually, let's start kind of like using this vocabulary: input, output. Okay.
Welcome back, Mosey Rotella.
We'll pause
It
this.
is an A-Day today. We are so happy to see you all. We have missed you and are glad to see each of you back.
Okay. Where was I? Yeah. Okay. So we've got our ordered pairs right here. Just helps us to kind of organize it, put it in order in terms of your X's. And now what we're going to do is we're going to put this in our mapping diagram. And so kind of what we're going to do is just do 2 ovals. We have our inputs on the left side. You have your outputs on the right. Okay. And again, you can think of those as X for your inputs and Y's as your output, because we are going to be graphing this, right? So it helps to be able to like distinguish between the X and the Y. Now, our first, I'll just put all our inputs in here: 8, 9, 10, 12, 14. And if you had multiple inputs, if you had multiple of the same input, like you had 2 8s, you would only put 1 8 in your arrow diagram, your mapping diagram. Okay. And then we're going to put our prices in our outputs. So 872, 901, 955, and then 1003. And so now we're just going to match up I might as well use all my colors here. We're just going to match our input to our output and see if we have unique matches here. Yep. 9 to 872, 10 to 901, 12 to 955. There. And so what we see here is that each of our inputs goes to only one of our outputs, right? And so what that means is that, I didn't actually include the question on this. The question is, shoot, what was the question? Dang it. Come on, Wishart, you're better than this. Apparently I'm not, though. Sorry. Should Jonah expect that the cost to ship a 15-pound box will be a unique cost? And so if we take a 15, well, we can see that it's going up each time. So yes, 15 pounds would be a unique cost. So yeah, yes, 15 pounds would be a unique cost. Sorry, forgot to put that in there when I was making these this morning. Yeah, because we can clearly see that each input, right, each amount of weight corresponds to exactly one price, right? We don't have 8 being 856 for one package and then 872 for a different package, right? Because that's not how that works when you ship a package, right? Okay. Joe needs to advertise his company. He considers several different brochures of different side lengths and areas. He presents the data as ordered pairs, side length here, an area here. So these are the ordered pairs right here: 424, 535, etc. And then what he does is he just puts in, what are we missing here? He puts it in the mapping diagram. So we're missing a 4, a 5, and we're missing an 8 right there. And so now what we're going to do is we're going to finish off the mapping diagram. I think I actually have a color that matches that. So 2 matches to 20, right? Boom, we're done there. 4 matches to 24, we're done there. 5 matches to 35, right? And you can see that in the mapping diagram, it doesn't have to go directly across. It can kind of go all over the place, right? 8 matches to 24, and then 9 matches to 27. Now, what you can see is we have 2 inputs going to 1 output. But that doesn't matter. We don't care if we have two of the same output, right? We have the same output here, we have the same output here. We don't care about that. What we care about is two of the same x values, two of the same inputs matching up. And they each go, they don't have two arrows going from them. So complete the arrow diagram, mapping diagram. Is the area of a brochure a function of the side length? Yes. Each input matches to exactly one output. Okay. Again, we do not care about doubles up in our y's or our outputs. We only care if we have doubled up in our x values or our inputs. Okay. Use tables to identify functions. Let's go to purple for this one. Frank records the ages and heights of the 6 students he tutors the table. It's a weird thing to do, Frank. Is the relation a function? And then we explain. Determine whether each input has exactly one output. Well, let's see. So what we can see right here is that we have 2 9s and we have 2 8s. Okay, so we have a repeat of our x values twice, in fact. So it's super not a function, right? So no, each input does not have exactly one output. Another way to think about this is you have a doubling or a repeat of your x values, right? A repeat of your x values. Okay, interpreting functions. Heather and her parents are going to an art museum for the day. The parking garage near the museum near the museum charges the rates shown in the sign right here. Is the cost to park a function of time? Well, let's see. And the idea, when problems ask a question like that, they are looking for that repeat of x values. If they have that repeat of x values, it is not a function. So these are inputs here for our time. These are outputs for the cost, right? So 1, 2, 3, 4, 5. Those are all distinct and unique x values. And they each correspond to one y value. So yes, each input has one y value. Okay. If they stay at the museum for 6 hours, should they expect to pay more than 25? Yes, they should, right? Because there's a pattern, right? So 6 should be 30, right? As these increase by 1, these increase by 5. It's a linear function because they have that kind of like pattern going up. It's a constant rate of change, okay? So yes, they should expect to pay. They will pay $30. All right, now, Heather claims that she can tell exactly how long a family was at the museum by how much the family pays for parking. Yes, she can, right? Yes, because each input has one output, right? That's the idea here. All right, I'm going to put this in notebook. Fold this in half. I'll go grab the notebook real quick. Go to the table of contents. I don't have to put it right a little later. Okay, so we'll actually skip a page here. We'll do, let's see, 31, 32, 33. And yeah, we'll start this on page 33. This is going to be 3-1, understand relations as functions. Yeah, let's leave a space in here. Let's see, 3-1. Understand relations as functions, and it's on page 33. All right, there you go, guys.